Hi, so I'm Jonathan Phillips. I'm an assistant professor in the program in cognitive science, and my graduate students are trained in psychological and brain sciences. So I'm going to tell you a little bit about cognitive science at Dartmouth, and I think that's going to give you a better idea of how cognitive science might relate to the kind of work you'd be doing in psychological and brain sciences. Okay, so at the broadest level, oftentimes when people think about cognitive science, they think about just a bunch of different kind of related disciplines that occasionally have something to say to one another. So for instance, you might think of the disciplines affiliated with cognitive science as things like education, linguistics, neuroscience, philosophy, psychology, artificial intelligence, or computer science, and anthropology. And if you think about the people on the steering committee in cognitive science, I think we're actually pretty representative of those different disciplines. So there's Adina Roskis, who's currently the chair of cognitive science. She has a PhD in both philosophy and in neuroscience. There's Dave Kramer, who works in both the departments of education and in psychological and brain sciences. There's Jim Haxby, who many of you will know, has worked both in psychology and neuroscience and is in PBS. There's Lindsay Whaley, who was previously the chair of cognitive science and works in linguistics in addition to cognitive science. There's Richard Granger, who works obviously in neuroscience, as many of you will know, but also has done interesting and important work in artificial intelligence. And there's Devin Balcom, who works in the computer science department on robotics, but also is in the program, affiliated with the program in cognitive science. So you might just think, okay, well, cognitive science is kind of like a bunch of these people from different disciplines talking to each other occasionally. And on the one hand, I think that's right. But I actually think that the cognitive science has much more to offer than just that kind of interdisciplinary crosstalk. And so I want to tell you a tiny bit about how I think of cognitive science and how it differs from, say, any particular discipline that might be affiliated with it. So traditionally speaking, disciplines and departments are defined by the set of tools or methods that they use to answer questions. So for instance, say you decide to do a PhD in neuroscience. So the tools and methods you're going to learn are methods and tools for studying the brain. So it might be at a cellular level, it might be at a whole brain level, it might be something in between. But now suppose you're a neuroscientist who has a question about decision-making. You want to answer a question. You're interested in decision-making. So then the point here is that the kinds of questions and answers you're going to get are going to be defined by the tools you have. So maybe you're going to end up studying something like dopamine and reward learning. Or maybe if you go to Dartmouth, you're going to end up studying something like how hippocampal replay might facilitate future decision-making. Okay, but suppose instead you decide to do a PhD in computer science. Well, I mean, the tools you're going to learn and the methods you're going to end up learning are going to be look pretty different than what you learn in neuroscience, right? So you're going to end up learning things about how to build good algorithms or build programs that make they're efficient in solving computational tasks. So what if you're a computer scientist interested in decision making? Well, again, the kinds of questions and answers you get are going to be defined by the methods you have. So you're going to end up working on something like, well, how do you build a good reinforcement learning agent to solve a complex decision task? Or how do you build an efficient search algorithms if you have a really large decision space to reason over? Okay, and suppose you do something totally different, right? You do a PhD in philosophy. Again, the methods and tools you're going to learn are going to be really, really different. If you're in philosophy, you're going to work on something like theory building, or you're going to work on conceptual analysis, you might work on deductive logic, things like that. And if you wanted to work, you're a philosopher who's interested in decision making, you're going to end up answering questions about things like, what are the rational constraints on an agent who's making decisions? Or you might answer something like more normative or ethical, like what kind of decisions should you make? Right? Or in a given circumstance, what's the right thing to do? So cognitive science differs from any of these disciplines in the following way. Cognitive science is not defined by a set of tools or methods. It's instead defined by a set of questions about how the mind and brain computes information. And so if you're a cognitive scientist interested in decision making, what you're going to do is a little bit different. You're going to think, okay, what's the form of the question about decision making that has been asked across these different disciplines? And once you understood that question kind of abstracted away from any particular set of tools or methods or frameworks, you can then think about how each of those different methods and tools helps answer and jointly answer and constrains a good answer to the question you have about decision making. And that's exactly the kind of approach that we try to take in my lab. So we try to answer questions that have to do with things that have been studied across disciplines, and we try to be really, really methodologically broad in thinking about how we might go about answering those questions. So to give you an example of questions that have been studied in my lab that also have been studied across disciplines, we answer questions like, how do you figure out what other people know, think, and feel? Right? Questions about theory of mind. We answer questions like, how do you make good decisions when there are more options than you could actually ever consider? And you might think this seems a little bit esoteric, but just consider a decision about what to have for lunch today, right? I mean, the number of actual options that you had for lunch was way larger than you could have actually considered. And if your process for that decision-making was to list every single possible lunch option and go through them and pick the best one, you would have never had lunch because you would have been sat around thinking about different options for too long. Well, here's another question that's been asked across a bunch of different disciplines. So how do we determine what the cause of an event was? This is a classic philosophical problem in some ways. Much more recently, it started to really be studied in causal cognition in psychology, and in addition in neuroscience. And now a bunch of computer scientists are really interested in doing sort of causal modeling and thinking about how that might be a good way of representing information. Or here's another question. How do we decide whether or not someone is morally responsible, right? This is both the realm of something that philosophers have thought about, but also social psychologists have thought about. And again, computer scientists are more and more recently thinking about how do you have computer algorithms that would assign us a moral responsibility or some kind of responsibility. So a central theme that I think runs through all of the research in our lab and kind of unites it in a way is that all of these questions have to do in some way or another with thinking about representing and reasoning over non-actual possibilities. So in some cases, it's kind of obvious, like decision-making. If you're thinking about different options that you haven't taken yet, that's reasoning about a non-actual possibility, a possible thing you might have for lunch. And how do you decide about a bunch of those? Or if you think about something like moral responsibility, the question then is like, look, to decide that someone is morally responsible, in part seems to involve you thinking that they could have done something else. And if they really didn't have any other options, if there was nothing else they could have possibly done, then it would be a little bit odd to hold them morally responsible. So what's interesting about all of these different forms of reasoning or questions that we have in our lab, they're all forms of high-level reasoning, and it seems like there's actually something very similar about them where they involve reasoning about non-actual possibilities. And so that's kind of a central theme that runs through a lot of the research in my lab. And if you think about our approaches to studying these questions and answering them, it draws on a bunch of different methods. So it's everything from doing developmental research, like studies with little kids and how they say reason about possibilities or how they think about theory of mind, to doing collaborative research with other labs who work on non-human animals. So for instance, we've worked with some labs who study non-human primates. Other labs, like there's a collaboration with Matt Vandermeer's lab looking at rodents and how they make kinds of decisions. And also the classic tools of cognitive psychology. So just things like response times or vignette studies and so on and so on. We've also used formal semantics to work on semantics itself, but also things like the tools of formal semantics, including modal logic, to think about how you might sort of abstractly model the kinds of constraints on decision-making processes or how you think about other people's thoughts. We've also used fMRI to try and understand how people represent counterfactual possibilities or non-actual alternatives when they're endogenously generated. We've worked on reinforcement learning and thinking about how that could actually enable you to make good decisions in cases where you can't think about every single option by generating basically a consideration set. And a recent one that we've been having a lot of fun with in our lab is a graduate student in my lab, Catherine Holland, has been thinking about how do you do meta-analyses of topics that we care about in our lab, but in ways that allow us to answer theoretical questions that weren't originally asked by the researchers who were creating the studies. So by doing a meta-analysis, in a way you can actually look across them, realize that they actually happen to have varied things that we would have cared about varying, given our theoretical approach. And then asking, can we find evidence by doing a meta-analysis across studies that we never would have been able to find evidence just by looking at any individual study. So that's just a very, very brief overview of what's going on in my lab and how you might think of it as relating to a lot of the research going on in psychological and brain sciences, which I think of as an incredibly integral part of cognitive science. But it's not the only tool that we can use in my lab to try to answer questions about how the mind and brain processes information. Okay, thanks so much. I look forward to talking to many of you.